Now let's see how our infrastructure is provisioned. You're seeing the Amazon Web Service web console. And here I have already created 3 EC2 instances that are already running and will be used in order to provision our Payara Micro cluster. Let me quickly show you that I also have created a virtual private cloud first that will be used to hold 3 subnets with separate IPv4 range addresses in order to contain the instances and services that will be used to provision the cluster. I have a subnet that will be used to hold our admin instance, more on that later, and 2 subnets that will be used to hold our Payara Micro instances. Now, I mentioned an admin instance before, and this is due to some limitations on the clustering model for Payara Micro. By default, Payara Micro instances communicate with each other using the multicast protocol, but unfortunately, Amazon Web Services and other cloud providers do not support this protocol out of the box, and there are some caveats to implementing it. To circumvent this, you can use all the discovery modes for the clustering features of Payara Micro, and the one that I will be using will be the domain discovery mode. That means that I'm going to use a Payara server installation in order to let other Payara Micro instances that live in the cluster talk to this installation and conform and join the cluster automatically. This creates some minor dependencies on having a separate instance working as a master node of source, but it is the easiest way to set up the cluster. Let's provision our instances then. We'll start with the cluster dash instance that will contain our Payara server installation. So with the instance already running, I'll SSH into the machine directly. And the only requirements that I need are a working JDK installation, and for these and the other machines I'm using Amazon Corretto, which is a fully certified OpenJDK variant that it's provided for Amazon Linux instances. And I also need the files for my Payara server installation. In this case I'm using 5.184, but you can use any of the recent releases. So what I want to do is to start add a main that will be used in order to coordinate my cluster. So for this example, I'm running a domain called microcluster, which is exactly equivalent to the domain 1 default configured domain that comes shipped with any Payara server installation, and it makes actually no difference. So I'm using the default values. So you can see here that the domain has started already, and the only thing that we want to do is to tail the log for this domain. So glassfish domains microcluster logs server log. Oh, it should be tail-f, okay, and it has started. Next, let's provision a separate machine that will be holding the web application that we have to use in order to chart our rating events on real time. So here on the web console you can see that I have a separate machine called micro instance 0 web, and this will be the node in the cluster that will contain a Payara Micro instance that has deployed our web application. So let's SSH into this machine as well. And here I have 2 files. One is the jar file for the Payara Micro application that I want to run, and this is version 5.184 as well, so it is good to have them consistent across the micro and the server version. And I also have the application's war file as well. You can see that it's named root.war, and I have done this in order for the application to be deployed on the context root. So to start the Payara Micro instance, I have to run this command, and of special interest, I'm naming my instance micro instance web, and I'm setting the cluster discovery mode to domain, which means that this instance will talk to a Payara server domain administration server installation running, and it will talk to it. It will locate it on the cluster dash hostname on port 4900. And lastly, I'm deploying the application that I have here. So previously, since this is a private network, I have configured locally the cluster dash hostname to the private IP address to the first machine. So I start by running this, and you can see here that Payara Micro instance is booting up. see here that the application has deployed correctly. And I can see here that it has finished the deployment. So the micro instance is telling me, okay, the application is deployed correctly. Here's the instance name that I have set up. And also I can see here that the data grid has reported that there are 2 instances on it. And with the instance running and the application being deployed, I can head to a web browser and show to you that the app's running without issues. So here, the rating browser feed chart should be showing my events on real time as they are being received. But that's the problem. We do not have any event generator instances running in my cluster. So let's solve that by making this cell machine micro instance 1 gen the first instance in the cluster that will host my event generator application. So to do this, I'll SSH into the cluster desk machine first, and from here I want to SSH into my third machine using its private IP address. This way it's faster. So of special interest on this machine, I have the Payara Micro jar file, and I also have my applications WAR file, the event generator application. So to run this, I do java.jar, and it's faster actually this way. I just run the Payara Micro jar file, and I set the cluster mode to domain discovery as well. Use the cluster dash host name for the Payara server installation that's working as a master node, and deploy the event generator application. So if I do this, you can see here that the instances are starting. And the application now has been deployed correctly. And I can see here that the status of the data grid is showing me that there are 3 instances as they should. One for the Payara server working as a coordinator, one for my web application, and one for my first generator. So if I go here on my web page, I can see here that new events have been generated by the first instance, and I can see here that for each point I have the current score that is generated. It's generated randomly by my application, and I have some opinions based on the comments on the text file that I showed you earlier. And I also know which events are which instances are generating these events, because I know the instance names that I have it. So remember that we talked about elasticity, right? How can I make this cluster elastic? That means that I need more instances to join the cluster as demand comes around. So let's simulate this by creating new instances automatically. The best way to do this is to use a launch template. That means I can quickly create new instances by using a template here on Amazon Web Services. So I have a predefined template called Event Generator Demo, and I have 2 versions, and of a specific interest I will create 3 new instances, and the only thing that I need to set up is the subnet for these instances. So let's say, for example, I do not want 3, I want 2 instances that will exist on subnet B first. And here on the name, I want to name them micro instance 1 gen, let's say gen B. And that's it. I will launch then. And with this, I can see here that these 2 new instances are starting. In the next part, I'll show you how these applications run in real time.